Greetings was asked to take a look at a couple problems in the homework. So this one was actually not in the homework, but I think it's worthy doing just to help us out with how to get R to calculate a p-value given a t-test statistic and a direction of extreme. So this is actually 5.4 from the textbook. Let's take a look at part A to start with here. And our instructions are to find the p-value for the given set of hypotheses and the t-test statistic. Also determine if the null hypotheses would be rejected at the level significance set to 1%. So in part A, what we see is that the null hypothesis is missing, but they gave us the alternate because that's really the only one we're going to need to be able to determine our direction of extreme. And we see that it is a greater than, which means we are one-sided to the right. So we're going to use that information to draw ourselves the distribution of the null with respect to t. So this is our t distribution, and they give us a t value here of 2.485. Okay, so that's roughly probably about there-ish. We know we are one-sided to the right, so what that means is that the p-value is going to be this shaded region right here. So whatever turns out to be that area right there will be our corresponding p-value. Alright, so we need to get R to calculate that for us. So to do that, we're going to need to know two things. First off, we need to know what the t-value is. Well, got that. And we also need to know what our degrees of freedom are. Well, degrees of freedom are n-1, so we know our degrees of freedom here are going to be equal to 25. So the command in R to actually do that calculation is pt. Now we've got to be careful because pt, just like p-norm, sums from the left. In other words, if I just put p-val equals pt, it won't give me the red area. It'll give me this cyan area over here. It's going to give me the area over here to the left, and that's not what I want. I want the area to the right of my t-value. So to be able to find that, since I know the sum of the total area is equal to 1, I'll simply subtract off this cyan colored area from 1 and I'll get the red area. So I'm going to take 1 minus pt, give our corresponding value of t, which is 2.485, and our degrees of freedom, which is 25. Okay, so let's go over and check out RStudio, get over there, and let's let it do that for us. So we're going to put in, I'm just in the console here, of course you would be typing this up perhaps in a homework assignment, pt of, let's see, what was it again? It was 2.485, 2.485, comma, 25, and when I hit it we get back an unexpected error. What did I do? Oh, I put in a period and not a comma. There we go. Okay, great. So just a good example that everybody makes typos, right? So what do we get? We get basically that the p-value is a little bit bigger than 1%. Not by much, but it is bigger than 1%. So if we were to answer the question, would we determine if the null hypothesis was rejected at alpha equal to 1%, our p-value is equal to 0.01 and then what? 0.00024. Which is greater than, not by much, it's greater than 0.01. And so in this case, since that is our p-value, and that is our level of significance, the p-value was greater than the level of significance, so we would fail to reject. Now, if it was, remember, it's greater than or equal to. If it's equal to, then we do reject, and it may be the textbook's not able to get that level of accuracy on the p-value, so the textbook might have said to go ahead and reject it because they may have said they were equal to each other, but they're not, so we will fail to reject. Okay, let's go ahead and do part B here. In this case, our direction of extreme is going to be one-sided to the left, taking a look at our alternate hypotheses. We're going that way. So again, let's draw ourselves a t-distribution here. We are centered at 0. Our t-test statistic came out to be 0.5, which let's say is about there-ish. And this time, we're in luck since we are one-sided to the left. Then that means that the shading region here, in other words, the region to the left, all this red stuff that I'm shading in here, that will be our actual p-value, okay? So in other words, this area here, all that area is encompassed right there, will be the actual p-value. So the command here to find out what that is, well, we need to know what our degrees of freedom are, so let's take a quick stop and do that. Our degrees of freedom here are equal to 17. So to find that shaded region there, we're simply going to say, okay, that's just PT this time. I don't need to do 1 minus PT. And then I'm going to put in 0.5 and put in my degrees of freedom 17. And the number it's going to return to me will be the corresponding p-value. So we'll put in PT 0.5, comma this time, 17. And we got back a p-value of basically, what, 68% or 69% if we round off. So let's go 68.8%. We'll go out 3 places. So 68.8%. So again, that's much larger than a corresponding level of alpha, which is what, 0.01. So again, we would fail to reject. Okay, so hopefully that helps a little bit with how to calculate the p-value based upon your t-test statistic. That's the point of this exercise. See you back here with some other ones soon.